So, welcome everybody. It's a pleasure to be here and present the final event of the Challenge Us 2023. And so today we will have a look to the results of the collaborations we had with the partners, the industrial partners that we collaborated in those months. So let me introduce a little bit the context. This initiative is inside the operation of the SoBigData research infrastructure, which is an European research infrastructure for social mining and big data analytics. And actually, our objective is to create a toolbox of methodologies and analytical process for model the complex social phenomena. And we are focused especially on working in what is or what if scenario. We are supported at the moment from the European by the European Union through several projects. SoBigData++, which is let's say the original one, the main one. Then the SoBigData PPP, which is a project for the long-term sustainability inside the S3 roadmap, because we were selected as a research infrastructure with good possibility of remaining active after the European projects, and also an Italian project, because we are the coordinator of the infrastructure. So in general, what we offer as SoBigData can be divided into those three groups. We provide the infrastructure with computational power, resources, dataset methodologies, and also open science tool from a side. In the other side, we have also several guidelines for the ethical aspect and legal aspect linked to the data analysis, because we are talking about social data, so data that coming from the behavior of the European citizens, and we need to take into consideration all the ethical aspect, especially about privacy. The last thing is the fact that we are a community. We are a community of researchers around Europe with several skills and topics of research that collaborate all together for solving problems or offering solutions. We are active at the moment on those 8 containers that we call research spaces. So we are focusing our activity on the fake news about social debate and misinformation analysis, demography, economy and finance, sustainable citizen, social impact of AI, health studies, social and industrial impact of next generation internet, pervasive intelligence, and disaster response and recovery. So those are the areas where our research is focused at the moment. And also the container where we provide all the technologies, methodologies, and dataset I described before. So from this, let's say, big research infrastructure with all those topics, we started also this initiative about the Challenge Us, and I will let you describe it directly from Rajesh Sharma from University of Tartu, which is this year, because Challenge Us move around Europe every year. This year is the organizer. So please, Rajesh, can you share the slides and present the initiative? Thanks.
Yeah, thanks, Roberto. So can you hear me? For
Yes.
some reason, I cannot share my screen. So I think maybe I have to give some rights. Something. Okay. You cannot start share while the other participants. So maybe you please stop sharing your screen. Okay. So can you see my screen?
Yes, please.
Okay, thanks for confirming. So I'll try to stick to time. I know we are short of time. So okay, so challenges is part of various other tasks which are come under SoBigData infrastructure project. And this particular initiative is to help small and medium-sized companies, especially with respect to their data management and other related data tasks. So one second. Okay, so we know that companies either consciously or unconsciously are producing a lot of data, and sometimes the firms do not know how to handle or get the maximum out of this data, and where this SoBigData infrastructure comes in their help. So it comes at their disposal as a kind of free help, and in the sense that we could help them in the sense of giving them suggestions, or we can even execute some of the data analytics or machine learning kind of stuff, where we can help the companies in analyzing their data, and even like in some cases we can even implement certain tools which they can further use for analysis and monitoring the data that is at their disposal. So that's the crude idea of this. Now there are various universities and research organizations which have been participating and have helped companies. For example, in Italy you have University of Pisa, Superiore School in Sant'Anna, and then CNR Institute from Switzerland, ETH, University of Sheffield from UK, and from Bulgaria, Center for the Study of Democracy, and then from Estonia, University of Tartu. Sorry, I missed some of the University of Roma. So yeah, I mean, and each of these organizations have their own expertise, and when the proposals were submitted, the main task was to match with a certain organizations which they have certain resources which are expert in certain areas which can help the companies. So the proposals were submitted across from different countries, from different for example, Estonia, Italy, Denmark, Switzerland, and Bulgaria. And so because mainly this infrastructure project is catering to EU. Now, some of the companies which got selected and have participated, like for example, TechnoInox, related with food and food related items that they produce. ATI, for example, related with architecture. Transcality, which is related to mobile and traffic data, and then Piconera again with respect to food. So in short, the background of these companies were diverse, and that's how they were helped in different domains. So I would keep it short. So this is the second version of challenges. There will be another version, but I think now it's over to Valerio, who will introduce the companies, and each of them will share their experience. So just a moment, I'll stop sharing.
Yeah, welcome again to everybody. Thank you, Rajesh, for your introduction. Well, it's time to go in the core of this event, and we have a lot of companies to present. I want to say that if somebody has question, can write the question into the chat here or in YouTube, and at the end will be a final session when we answer the company's answer to all the questions. So stop with the time spending, and we go directly to the first company, that is Spazio Dati from Italy. Is a startup starting in 2013 and collaborated with Unipi eCube Group. Okay. Spazio Dati, are you there?
Hi, yeah. Leonardo, can you share? Okay.
Yeah, I recall that you have 10 minutes.
Yes, sorry, I don't see.
I invite all the speakers to maintain this timeline.
Can you see the
Okay.
screen? Sorry.
Yeah, now we see your screen. Thanks.
Yes. Okay, hi, I'm Giacomo Berardi from Spazio Dati, and me and Leonardo Calamita from University of Pisa are going to present an application of large language models for extracting entities from company websites. In particular, our goal is to extract people and their roles in the companies. Next. Okay, this is the outline of our presentation. Next. Oh, okay, in Spazio Dati, we are used to work with corporate data. We collect both structural and structural data from many different sources. Then we use this data for feeding our services. We provide web applications for exploring and extracting useful insights in the business domain. Information about millions of companies and people. For example, Atoka, one of our product is a search engine of Italian companies that allows you detailed searches across different semantic domains. And next. So in Spazio Dati, we are experimenting already with large language models. We would like to use them principally for extracting and aggregating new information, but also for improving the user's experience with the new language interfaces. We are using LLM, for example, for analyzing complex documents about market sectors analysis, and for giving
Sorry,
users.
Giacomo. Sorry if I interrupt you. There is a black window that covers the right part of the slide. Probably it's the window of Zoom. If you can reduce it or move it.
Yes. Sorry, it's completely blocked. So okay. So maybe I try to. Okay. Shouldn't be there anymore now.
Oh yeah, if you put it perfect.
There.
Thanks. Sorry for the interruption.
Okay. No problem. So we are using LLMs, for example, yes, for market analysis, but also internally for as a tool for our employees for exploring the many heterogeneous data sets in our data lake, even without a technical background. Next. So for challenges, we wanted to test LLM for an entity extraction task over web pages. We already have in Spazio Dati a system for extracting people from web pages related to Italian companies. Pages that we constantly crawl from the web. So we hope that with the LLM, we could catch more mentions of employees in HTML data that is usually difficult to analyze. So next.
Okay, so I'll take the presentation from here. I'm Leonardo Calamita, as Giacomo said, and I worked on the technical side of this project together with the folks at Spazio Dati and Professor Paolo Ferragina from the University of Pisa. So as Giacomo already said, the main task that we were trying to accomplish was starting from these web pages of Italian companies. We were trying to extract all the people's names and possibly their job position. And Spazio Dati has already their software to do so, and we were trying to accomplish this using large language models in particular, and specifically we wanted to see if large language models could be first and foremost effective, so they could actually do the task in the right way, and also efficient in doing so. And as we will show, we saw that basically they are very effective in tackling this kind of task, but at the same time, they're not particularly efficient. So the dataset was composed of 100 HTML pages, together with all the data that Spazio Dati's system had already extracted. So we focus mainly, as we already said, on full names and if they were there, their job positions. We extracted all the visible text from the HTML code using Beautiful Soup, which is a Python library, and then we applied some simple text preprocessing steps on the extracted text. This is the overall pipeline that we use to extract, fully extract names and the job positions. We started from these input pages that we just saw, and then we created a prompt. I will briefly show it here. The prompt basically asks GPT to extract all the names and possibly the related job position of all the people that are comprised in the web pages. And we also try to encapsulate an example to show it the possible structure that we wanted to have in the output. So back to the pipeline, we gave the prompt with the input pages to ChatGPT. We used both 3.5 and 4. And then we applied some post-processing to the results, mainly to stick to the structure that we wanted and to remove duplicates and aggregate partial duplicates, and to also possibly reduce the hallucination. So these are the bare bone numbers that we extracted. So Spazio Dati system managed to extract about 500 people, and of those 500, almost 300 job positions from the 100 pages in the dataset. Using the GPT 3.5 and 4, we managed to obtain many more both people and job position, especially job positions. But still, looking at this number, we do not know if these are hallucinations or these are issues with Spazio Dati's code. So we dive deeper into the analysis. And this is a comparison of the between the results that were obtained by Spazio Dati's tool and the models that we used. Basically, we used Spazio Dati's result as ground truth in a way. And we did both exact and partial meshes in order to increase the recall in a way and to be more sensible to possible changes. And in particular, we also checked both just the name extraction and names and job position extractions. And as we can see, GPT-4 manages to basically overlap itself with the results of Spazio Dati with a 95% partial name matches, but the names and job position pairs are not that accurate as well. And this may be, again, because of Spazio Dati's results, maybe there may be issue there, or because the models forge stuff that is not actually true. This is another comparison still with Spazio Dati's results. We are showing here the number of pages in which the models managed to obtain more or less names with respect to Spazio Dati's results. And we can see that GPT-4 in half of the pages manages to extract more people than Spazio Dati. And so at this point, we proceeded with manually annotating 35 randomly chosen pages among the 100 that we had as a data set, and extracting all the names and all the job position if they were there. So we ended up with 250 names and 172 names and job positions. And as we can see, GPT-4 basically is almost perfect. It manages to get almost all names and almost all the job positions, while Spaziodati's results are quite lackluster in comparison, and we also try to include partial matches in order to increase the recall in this case, but still the results are still pretty much there. And now we will show a couple of simple examples in order to perform a qualitative analysis of the results. In this case, we had a very schematic text. There are just 5 names and no job roles. As we can see, the text is very, very schematic. It's not really natural language sentences, and Spaziodati manages to obtain 2 of the 5 names and no job roles correctly, while the models in this case are hallucinate a lot more. This was one of the few cases in which they hallucinated this much, but I thought that this example was particularly interesting because GPT-4 managed to extract an extra name on top of the 5 basic ones, which was actually comprised in an email address. And I thought this was really interesting. Also, this was another example. This is another example. It's a very long text. There are a lot of names. A lot of those names are not Italian names. And all the jobs role presents are quite fuzzy in a way. And Spaziodati manages to obtain just 26 out of these 62 names. And none of the foreign names are actually extracted, where the models manage to extract most of the names and most of the job roles, especially GPT-4. So, in conclusion, we can say that we managed to find some issues with Spaziodati's approach and a high number of errors in general. And large language models are great at tackling this kind of tasks. In particular, we saw that improving the textual data quality helped a lot with the results. Of course, using better models leads to better results, and specifically for GPT-4, using the system role in the prompt also improved the results. Hallucinations are still a thing. They are still there. They are not particularly problematic in this specific task, mostly because they are quite easily recognizable on the post-processing steps, so they can be tackled in a way. And as for the feasibility of using these models, GPT-4 is not particularly fast, and also it is quite expensive. And in order to tackle these problems, we thought about possible future developments. First and foremost, we could use GPT-4 to create an actual dataset with which we could train open source models like Llama 2, for example. Or, for example, we could use an hybrid approach in which simple pages are sent to Spaziodati's tool, while the complex ones are sent to GPT-4. Of course, this leads to the other problem of how do we decide which are the simple pages and which are the complex ones. And as last, we thought about using an R model to extract just the names, and then to send the textual window around the names to GPT-4, and to extract the job position from those snippets in order to reduce the number of tokens that we are sending and that the model has to process. Okay, so this was everything, and thank you for your attention.
Thank you. Thank you to Spaziodati. Perfect. In time, I recall that the question will be at the end, and in the next days, we will share a form to all the companies in order to get some information about level of satisfiability and so on. We go to the second company, that is ATI Project. It is an international company specialized in integrated design, architecture, and engineering. And they collaborate with CNR and Scuola Normale Superiore. ATI Project, are you there?
Yeah, hello everyone. I'm Giacomo Marani.
Well, I leave you the floor.
I will share my screen. Can you see it?
Perfect, yeah, you can see.
So, well, okay. So, as you introduce us, we are an architectural engineer construction studio specialized in the BIM-based project. In this challenge, our goal is to develop a tool that utilizes extensive data from our past project to ensure informed decision in early stage design of a building. Let's say all the knowledge acquired during the past year is enclosed in our server that hosts more than 500 complete projects from the design to the construction. And all these data that are more than 35 terabytes are organized and stored within different disciplines and different formats, and regardless of materials and resource usage, cost information, technical data, and energy efficiency. The challenge lies in effectively integrating and extracting valuable information from them. It's not easy because a lot of them are proprietary file, other are not structured data. And we collaborate for this reason with you of SoBigData researchers to tackle this challenge. One of the primary challenges in our industry is assessing the building environmental impact during the early stage of design, which is, let's say, the most important phase for minimizing the material usage and the carbon footprint of the building. Life cycle assessment analysis is the instrumental in this, as it evaluates environmental impacts throughout all the stage of the building life cycle. We can categorize this stage into three main phases based on their footprint impact. And the material production and construction phase, the operational and maintenance phase, and the end of life of the building. As you can see, the operation phase is particularly crucial and critical, as it accounts more or less for half of the carbon emission. And this phase impact is largely driven by the building energy consumption. That is a metric that typically requires extensive data collection and also an effort during this early stage to create an energy model with not all the development of the building already structured. So it's very difficult for us to determine how much will be the energy usage of the building. In response to this challenge, our project is focused on developing a machine learning model specifically designed to predict this energy consumption value. And to effectively demonstrate and evaluate our proof of concept, we are focusing our scope on a specific building sector, on the educational sector. We have a lot of projects about school and university. And these decisions allow us to customize our input feature for the contest, ensuring a specific target and relevant analysis. So our data collection process begins with an in-depth analysis of the building's energy certification, known as Legge 10 in Italy. This is a mandatory national standard for all completed construction projects, and the information is compiled in a detailed PDF format that is structured for some projects. In other projects, depending on who redact this type of certificates, could come from different software, so they have different structure. It's not easy to extract all the same value from all these documents, so and we need also to parse them at the end. And this document contains comprehensive data on various aspects, such as the energy consumption patterns, utilization of renewable energy source, and other efficiency metrics of the building system. Additionally, they provide crucial geographical information, including the climate condition and the location of the specific building. They are almost all in Italy, but we can have different kind of climates depending on where in Italy, north, south, or middle of Italy. However, while these documents offer a wealth of information, they do not always contain every piece of data we require for our analysis. There are instances where specific data are missing or not covered in the standard reports. And to address this problem, we go to the core of our sector. Let's say this is our BIM project based, that is the BIM, the Building Information Model. So the information now is contained inside the 3D model, where is used now to resolve all the integration problem between different disciplines inside the industry. So by architectural, structural, and mechanical engineer. So it's a software for coordination, but this method now is widely recognized from the construction sector and is more and more used. So it's good for us because all the information now is stored inside this model. So all the aspects of the information about a project, from the geometry to the energy efficiency, should be inside this model. So it's easy to extract for it because the format of the file are the IFC file, that is an international foundation class. And these IFC files are a globally recognized standard for sharing and exchanging construction and facility management data, offering a more comprehensive view of a building. Plus, this is an open BIM format. And from them, we can identify all the key features that are significant for machine learning model, not only for the purpose of this proof of concept, but also for all the variables involved in the life cycle assessment method. In addition, we try to manage other data from national open data from ENEA. These provide key information on energy performance and emission, enhancing our machine learning model for a more detailed analysis of energy use and carbon footprint in educational building. And in summary, our project has successfully used machine learning to predict how energy efficient a building will be from the start, the early design stage. We focus on data that are most impacting for the building energy consumption, that is the envelope of the building. So a lot of data come from the EFC file, because the windows bore ratio, for example, is something that could not be extracted from the PDF format, but could be accurately known by the FC, because all the area of the wall or the respective area of the windows could be extracted for them. And we achieved a good result in this, but there is for sure more work to do. We need to get more data from different types of building and make our model fit well with the full life cycle assessment process. So we look to expand this proof of concept. There are key areas we need to address. One of our primary limitation is the availability of the comprehensive data. Of course, it's not easy. We need to expand it, because for better results and increase, we need a lot of data, more data than we have in our server. So we need to adjust it so it can be used for different kind of building. And also, we look to establish partnership with the agency, other stakeholders. Also, to extend the input feature, considering all the relevant data associated with the building project. For example, to extend it also to the bill of quantities and also the life cycle cost analysis on this. I want to thank you for your attention and support, and also want to thank the Scuola Normale Superiore and the CNR of Pisa that help us to develop this tool. Clara and Giulio, thank you. So that's it.
Thank you, Giacomo. Thank you, Nazi Project. And we go to the third that comes from Italy. It is Sofotec. That is Sofotec works on inspection and certification in the construction, environmental, and marine sector. And I think maybe Maria Vittoria there.
Yeah, good afternoon.
Oh,
I'm here.
give you the floor.
Laura, can you share your screen?
Yeah.
Thank you.
Okay.
Good afternoon to everybody. My name is Maria Vittoria Brandi and I work in Socotec. Socotec is a company leader in TIC, testing, investigation, inspection and certification, and operates, next please, in the following business lines: building real estate, next, infrastructures, industry and equipment, environment, and training certification. Especially in Italy, we operate in the infrastructures, environmental, and marine sectors. The service offered by Socotec enables customers to know the health status of the environment, the infrastructures, and the civil construction. During our activities, we acquire a wide range of data coming from different BUs and covering all the fields in which the investigation is developed. In particular for environmental part of fields, the results includes chemical, physical, and microbiological analysis carried out on different environmental matrix like sediment and water. And in addition to this type of analysis, aspects concerning pollution are also investigated in environmental matrix and in the organisms that populate the environment. However, the big quantity of results make it so difficult to relate them, especially in terms of predictive analysis. To address this challenge, we participated in the challenge with the better management and with the prediction methods, we could help the safety and development of our employees, of the people, and the territory in where we operate. In particular, predictive analysis on environmental data give us the possibility, with the use of the interdependent data, to have an estimate of the real values of the data chosen as a variable. Data, next please, analyzed in our study come from an environmental marine survey, which one of the scopes of work is investigate the health of the status of the area. During our environmental fields, we sampled sediment, water, and organisms, but the type of the data are so different because we have data from point samplings, one result for each sampling, and data from in continuous sampling. We have a big number of results for each sampling. For the prediction method, we use multi-parameter probe data because with this type of equipment, we can make a in continuous sampling, and so we have a big number of data. At point sampled with multi-probe, we have measurement along the entire water column, investigating about deep water to 7,000 meters up and in 10 different points. The variable which we have done the prediction is dissolved oxygen, because in general this is an environmental variable with strongly interdependence with other variables like temperature and depth that can be measured in easier ways. we then asked the research team to predict this variable in depth of 2,000 meters to 4,000 meters, and values, but these values had to be measured with the multi-probe. So with that we have to could have a comparative measure to check the validity of data prediction. In this map, there are points sampling with the probe. We sampled center well and each north well, and Dr. Laura Pollazzi will talk you about prediction method used.
Okay, can you hear me?
Yeah.
Okay, perfect. Good evening to everyone, of course. And from our side, from the technical side, the first job was to, let's say, translate the business question into a research question. So for first, we perform a data exploration in order to understand which are the relationship among the measure that Socrates give us, and also which is the strength of this such relationship. And here are shown the results about Gemini, that is one of the wheel, but we conducted all the experiments on all the wheels. So then we pass to look at two different tasks. The first one is the oxygen prediction for the central wheel, and for this we experiment several methods, several algorithms. And then for the second task, we try to apply the model that we have learned in the phase before to the feeder wheel and vice versa. So for the first task, the oxygen prediction, we experiment several algorithms. As you can see, we experiment linear regression, ridge, lasso regression, but we obtain the best results by using a random forest and multi-layer perceptron, that is a kind of neural network. Also, to go deeper in the investigation, we use an OLS model with two implementations, the forward and the backward selection, in order to understand which are the features, so the measure with the strongness, the stronger relationship with the oxygen. So in the first implementation, we try to add at each iteration a new measure and try to predict the oxygen, while in the second implementation, we start with the entire set of features, and then at each iteration, we try to remove a feature. And as you can see, we obtain some shared features, so some shared measurement that tell us that there are some let's say, constant relationship among this measure and the oxygen. Finally, we move on the second task. So we start from the learned model. So what we know, the way in which we know we can predict the values for the central wheel, and we apply this model to the data from other wheels that are near the central one. Of course, the performance of the model go a little bit worse, but this is something that expected. On the other side, on the second column of the slide, you can see the mirrored part. So we learn a new model trying to predict on a closer wheel to the central one, and then we apply this model to the central wheel, and we obtain best result compared with the first comparison. So I leave the floor to Maria Vittoria in order to conclude our talk with the final remarks.
Thank you. At the end, the results obtained were compared with the measurements made with multiprobe, and the results are in line. And in second, we compared our results with results from literature studies and are in line. Next, please. In conclusion, we can talk about the advantage obtained from those results. We have a different impact on different actors. We have a positive impact on our company because thanks to this method, we can have an integration between the different information, give better knowledge on our work, increase the power of BIOS cooperation. We can develop a new service or of prediction to help prevent the internal and external safety of the project and reduction carbon footprint. We have an impact on our clients because we can make a data collection services, define the possible scenarios could will affect with their activities, and we can make a project strategies development or preventive action, and then we can have a positive impact on our territory because with this type of studies we can have an environmental preservation and a better acknowledgement on our territory. Next, please. Thank you for your attention.
Thank you, Maria Vittoria and Laura for the presentation. We go to the fourth company, that is Tecnoinox from Italy, and it is a manufacturing Italian company operating the food servicing business. They collaborate with CNR.
Thank you. Can you hear me?
Yeah, I can hear you.
Good afternoon to everyone. Let's introduce myself and my colleagues. I am Laura Belbon. Here there's Laura Gentili and Riccardo Giacomini. The first part of the presentation, we just introduced our company, and then we describe the needs that lead to the activity, to the challenge. So Tecnoinox is a leading company that has been operating in the food service sector for over 35 years, and is specialized in the developing, design, production, and sales of professional cooking equipment. The company is located in the northeast of Italy. It has 3 plants, all based in Foggia, province of Pordenone. Today, the company employs over than 95 people. As you can see from the bottom side of the slide, Tecnoinox cover the full product cycle. So from the design of the cooking appliance, the finished product. And it also covers many type of services in terms of transport, after-sales support, warranties, and also after-sales services. We can go ahead to the next slide. Tecnoinox was founded in the 1984 as a manufacturing company in the supply chain of stainless steel products. It then began to develop its own products, starting from the salamander in 1986, as you can see from the first picture on the left side of the slide. Today, Tecnoinox offers a complete range of modular cooking products and home steamers. So during the years, introduced many types of cooking equipment. So we can go on the next slide. That talks to the Tecnoinox market. In the last 6 years, Tecnoinox has opened up to new markets in Asia and Africa, but his core market business is still in Europe, and the market in Europe is characterized by a strong seasonal dynamics that strongly influences the sales through the year. And this is important because as Tecnoinox grew in size, it became increasingly important to control the total value of stock in order to maintain a financially healthy balance sheet and also to minimize the space taken up by stocks. We have a lot of data. We collect during this year's all the data from over 10 years of stock movements, production and sale orders, component counts and bills of material of every component and product. And with this amount of data, sometimes it's difficult to interpret this information. And at the moment, it is also difficult to predict how quickly the warehouse will be empty. And this has a consequences for the identification of the proper marketing and operational strategy for the company. So with this large amount of information, it would be ideal to learn from the existing amount of internal data in order to calculate the ideal quantity of production order for each component. And to meet these requirements, the first step should be to understand how quickly the warehouse empties. Okay, conclude my first part.
Okay, so let's say that we collaborated with TechnoInox, the CNR in Pisa, and actually from the statement proposed by them in the submission, which was the idea of finding a new way of evaluating how much fast or how the storage can be predicted, the storage occupancy can be predicted. Let's say we translated it into a possible analytical process, which was the creation of models that try to identify the speed of the drops in the product in the storage. So starting from the data of 4 years data, actually, we started with that from the 2018 to 2022, and we have more than 4 million movements, let's say, storage movement, about 30,000 distinct products. And plotting, let's say, if you look at the data and look at the variability of the storage for each single product, you have the behavior like the one that you see in the bottom left of the slide. So some of them are pretty regular, some of them has spikes, let's say, and some of them are completely, let's say, different from between in different period of the year, or even very let's say sparse in time. So the idea is to first of all identify, have an automatic way of identifying the drops of the product. So the drop is defined as a sequence of point that go down in the storage, so without any reorder, let's say, in the storage. So you see that from the behavior on the left side, we have identified some small drops during time. So what we want to do is to extract a model which are able to represent those drops, especially the speed, so the angular momentum of the line representing drops. So from those drops, we got some speeds. We can call them speeds because that represent in different period of the year how much fast a product leave the storage. So at the end, in practice, what we had is a prediction that giving a certain point in time when we make an order in our storage, gives us the angular moment to for the usage of that product. So as much the angular is small, it means that you sell things very fast. Or if the angle is bigger, it means that it is selling things slowly in time. In practice, we tested this algorithm between having a training between 2018 and 2021 and testing it in the 2022. So those actually at the beginning we tried to have an exact correspondence between what we want to predict and what is in the model, and but actually this means that if in the period of time that we analyze that there is there isn't a drop in the past, it means that it will be difficult to predict in the future. So we also developed a method that's trying to find the nearest, let's say approximated prediction considering a window of time. And so as you see with the exact one, we predict the 70 with an accuracy of 76%, but with a prediction rate of 50%, going to clearly prediction rate 100% because we look for the closest without any limitation in the time slice. But we lose a little bit some of the accuracy in this, but not so much. So it is pretty interesting to see. We also considering the fact that between 2018 and 2021 there is the COVID, so there is a situation that is not so normal, let's say, that may affect the result, and actually this is true. So looking, for example, for testing only the 2018 and predicting 2019, so before COVID happened, completely, we got an highest percentage. I mean, not the higher percentage, not so. I mean, not so big the difference, but actually there is. Mostly also considering the kind of error that we do. If you look at what happened in the whole period, you see that there is also the distribution that is not completely balanced, but in the other case, it's really balanced. So it means that the error is not toward a direction or the other. Finally, we tested it also considering specific categories of products. In particular, we want to report here the consumable, which are a category of it's a category of product that it can be bought in a large quantity and then slowly used. And the result actually show a little bit improvement again. So we go toward 82% if we got the exact, but 81 for the nearest one that give also a prediction rate of 100%. And you see again, it's very neutral, the kind of error that we did. So I didn't give you all the details because there are many parameters that can be used in order to analyze different things, like the period of time and the time windows for each singular model, but we have not so much time. So let's go on with the last test that we have done. It's about the product based. So when here we report the results, we report the results according to the number of drops that we predict. In this case, we collapse the result in product, which means that we can consider all the drops predicted for a specific product as the same the same instance. And so, I mean, here there is also the dimension of saying, okay, when we consider enough for a product to be correct or not. And this is what we see in this plot. So for different threshold of error, so 5 degree, 10 degree, 15 degree, is the degree between the actual drop and the predicted one. And in the other side, we have the amount, the percentage of drops that should be correct in order to consider a product well predicted by the algorithm. So for example, here you see that considering the 60% and 15 degree as a maximum error, we have 73% of accuracy. It means that 73% of the products that we have can be predicted with a good accuracy. So what's important here is the fact that this is a proof of concept as the others, and we think that this can be used, this algorithm can be used for the optimization of storage, in the sense that knowing how much the product will last give you an idea of how much you need for a specific period, especially for the consumable, which is a good category to be predicted. But also can be used in order to evaluate if the situation in a certain moment is an anomaly, if I'm selling too much or too less, considering the previous period, because we have the predicted and the actual. The error may be simply an anomaly of the specific case. And since the TechnoInox has already a system about ordering the product, this can be an alternative or play together in order to have better accuracy. In general, from this point on, for sure is to handle some special situations, especially for products that are not very systematic, but can be also, let's say, identified a priori and considered in a different way. So I don't want to steal more time. It was a pleasure to work with TechnoInox, and I leave the floor to Valerio. Thanks.
Thank you. Thank you, Roberto and TechnoInox. And we go to the next company that comes from Switzerland, is Transcality AG. And Transcality. Okay.
Perfect.
It is a collaboration from ATH and CNR, and I leave you the floor maybe to Gabriel.
Thank you very much for the introduction. I'm sharing my screen. I hope you can see it. Let me know if not. Now you should be able to see the slides. So very happy to be here today to present our results from this SoBigData Challenge here at US 2023, collaboration of ETH Zurich and us, Transcality. Maybe some more information on the collaboration setup. So on the one hand, we had the team from ETH, the research group of computational social science, and they basically focus on bringing modeling and computer simulation of techno-socioeconomic processes and phenomena together with related empirical, experimental, and data-driven work. So this was very much actually in line with our project. They also combine perspectives of different scientific disciplines and bridge between fundamental and applied work, which was also necessary in our challenge. The team there consisted of 5 of us, Sajid, Javier, Rohit, and Professor Dirk Helbing. And on our side, we are Transcality, an ETH spin-off, and we are active since 1.5 years, mainly in Switzerland, Germany, and Austria. We focus on automating the generation and the calibration of traffic simulation models, and these models are then applied for estimating the impacts of traffic management or planning measures on indicators related to congestion or to air pollution. Our team consisted here of Matteo, Lucas, and myself. So what was the problem we tackled? As I think everyone knows, traffic is the main contributor to air pollution. especially in cities. And of course, traffic operation and infrastructure planning has an essential impact on such traffic conditions and thus on emissions. For emission-sensitive operation and planning, the respective models have to be brought to practice, and vice versa. Integrating emission data into traffic prediction can also enhance the predictions accuracy of traffic. So we had here the objective in this project to analyze historical data and to identify patterns and trends in the emission data and also relating it to traffic flow data. More specifically, we wanted to investigate the potential of regression models for predicting real emissions based on simulation data. So the research question could be, since qualitative and quick to be deployed models are still missing, can an approach based on statistical and physical models lead to valuable results in that sense? Now, I want to explain our approach. So we basically had 3 different types of data available. On the one hand, we had empirical traffic counts, and from measurements in the city, we had, of course, OpenStreetMap data available, and we also had empirical emissions data for sensors in the city of Zurich. Our job as Transcality was to create a traffic and an emission simulation based on the empirical traffic counts and the OpenStreetMap data. We thereby used the open source tool Sumo and the emissions model based on the Handbook of Emission Factors for Road Transport. This simulation allowed us to create the simulated traffic and emission data. And based on this simulated data, the OpenStreetMap data, and the empirical emission data, our colleagues from the ETH Zurich defined a lasso regression model to relate those data with each other and to see how much we can gain knowledge from simulated data. A bit more on the data sources we used. So regarding the traffic counts, we took measurements from so-called loop detectors in cities for the months January and September 2021 in Zurich. Regarding OpenStreetMap, we looked into tree counts, street closeness, street canyon related parameters, elevation, and the orientation of the streets to the sensors. Regarding empirical emission data, we focused on particle matters data 2.5 and 10. And from our simulation models, we extracted traffic counts and volumes, average speeds, and traffic-related NOx and PMX. As I've already indicated, our use case was the city of Zurich, and there we had chosen one sensor location where we actually had, of course, our emission sensor. Here you can see a small map. You can also see the simulation model here for this intersection, which we actually extracted from the large simulation model we had available for the city of Zurich. Did you get a feeling how the data looks like? We have plotted here the particle matter measurements, the empirical ones on the top. So you see PM 2.5 and PM 10 and the respective time series for September 2021. And on the bottom, we see the normalized data coming from the simulation models. Basically, what we're showing here is 4 different time series. It's the NOx and the PMX and traffic count and traffic average speed. What we can see here is that the simulated emission data is more or less driven by the traffic counts, as these time series are more or less overlapping. We analyzed the correlation for these simulated data and the empirical data. As you can see here, on the y-axis, we always display the empirical data, and on the x-axis, the simulated data. As you can see here, for the PMX, for the traffic counts, and for the average speeds and the NOx, they are mostly point clouds when you compare them to the empirical measurements. So we don't see a very clear pattern here, but this was expected as we deal with very complex systems. Nevertheless, we started to build a regression model. The methodological steps here were first to decompose the data into seasonal and trend components, and also removing the noise components from these time series. That means we denoised them. And then we wanted to find the transformation to relate the trend of the simulated emissions with the trend of the real emissions, and the seasonality of the simulated emissions with the seasonality of the real emissions. And these functions here were approximated with a lasso regression with a polynomial feature up to the degree of 2 in this project. And now I want to show you some results. So for example, here we see the original time series for the PM 2.5 and the decomposed results. So first we can see the seasonality pattern, the trend, and the noise. And then we compared the trend for the empirical measures and the seasonality. So here you can see the different rows with the trend and the seasonality from the simulated variables. And what we can see here is already at least an improved correlation between certain variables, which we already considered as a good result. We also trained the model on a certain part of the data set, of the denoised data set, so to say, and then also tested it. And we can already see here in these correlation plots that in fact, the correlation of the denoised data is a bit more clearer than what we have seen before. And now I already want to conclude first about the modeling results. In fact, a model-based estimation with 2 months of data and only from one location are not yet accurately depicting the real emissions, but this was expected as traffic and emission itself are complex topics. However, we really found out that one can devise a sample regression model that indeed improves the accuracy of the simulated data by applying these regression models and by learning, so to say, more about the noise and the error. We have certain limitations to our project due to time constraints and budget constraints, of course. So we were not able to calibrate the emission. We used simulated traffic instead of empirical data one for this specific use case, and we considered only one location. That means in the future, if we consider multiple locations, calibrated emission modeling tools, and maybe other statistical models, we can even further improve the results of this project. Now, also on the collaboration process, I think both teams would agree that we had a very good collaboration. There was a very quick onboarding and an efficient distribution of tasks, and therefore also of the usage of the respective skill sets. And we had continuingly open discussions about how we should proceed. As a summary for us, the SoBigData Challenge 2023 was very great to foster research and development works. As a very young startup, we have only limited budget, and that helped greatly. I think for the cost team of ETH, they had an interesting field of application to bring research to practice, and both parties have expressed their willingness to continue this collaboration at a scientific level in the future. And last but not least, I want to say also thanks to SoBigData for this opportunity and all involved supporters, and of course to the team. Thank you.
Thank you. Thank you to everyone involved in this project, and Gabriel for the presentation. And now we are going to conclude this first section of a round of presentation with Pecora Nera from Italy. That is an Italian publishing company specializing in independent publication of guides of food and wine in Italian cities, what is offered by Italian cities. And they collaborate with the University of Rome La Sapienza. I already see the slide, so I leave you the floor.
Okay, 1 second, because I have to increase the size. Sorry. Do you know how to? Okay. Let's see whether.
Okay.
Do you know how to move the top part to access the tab? Okay, let's see. Let's do the following. Okay, so actually I'm Andrea Vitaletti from Sapienza, representative of Pecora Nera wouldn't join, but they recorded the video, which started in a very funny way, because one of the characteristics of La Pecora Nera is to provide independent review, and so they are all the inspectors are anonymous. So I will show you the video very quickly. It's a 3-minute video. Oh, sorry.
We can.
1 second, because we should see the where are the subtitles? Okay.
We cannot see, we cannot hear the voice. Not hear.
Sorry. Do you know how, what should I do? I think it's a matter of more.
Otherwise, if you can send us the video, we can.
Okay, so the easiest way, if you go to the website,
you can copy in the chat. Maybe you
Yep.
get the chat. You can copy the video in the chat. We ask to organizer to try to.
Here is the website from which I will basically follow for the presentation, and in the middle there is this video. Anyway, the main idea, you can even see the video alone. It's nice because Simone basically is telling what is the role of La Pecoronera. They are a publisher of a food and beverage guide. Their unique characteristic is that they use to visit restaurant in complete anonymity in order to basically do not be recognized, and so be free to provide their independent review. They already have some, relationship with data management, clearly due to the fact that they ask the inspector to make a kind of ranking of the restaurant based on the votes on specific dishes. And in particular, they also had the first experience of collaboration with us and with another startup named Posti and with a company named Albaviva in order to build a certification on-chain of their guides, so on the blockchain. And then they came to us asking for the following. They have the following idea: why don't we build a game based on food, where basically we analyze the concept, the idea of food pairing. What is food pairing? Food pairing is the ability of pairing food according to some specific property, in order to build a game in which basically people buy a box in which there are possible pairings. They start tasting the pairings, then they provide their own ranking, and this own ranking is compared to the ones that has been obtained by data. And so the question by Simone and La Pecoronera was, can you please help us in distilling the ranking among ingredients, or to build a tool which allow us, given an ingredient, to find what are the best matching. This is clearly not new. Let me show the poster that we presented in Maker Faire. This project has been hosted in Maker Faire recently. So basically the idea is that we extract data from the recipes available on the internet, and we build a graph in which basically the nodes are the ingredients, and exists a link between the nodes if exists at least one recipe in which those ingredients appears together. And then with standard technique, we build an embedding. So basically we have a representation of each node as a vector. In this specific case, it's a 64 vector space. And through this embedding, we can compute the similarity among ingredients. Okay, so here you have an example. If you put pecorino romano, which is one of very famous ingredient in Roman cuisine in particular, you get those old ingredients which are paired according to the recipes. Okay. Clearly, this is not a new approach. Indeed, this work has been based on a publication on Nature that you can find. Oops, sorry, that you can find. Why I cannot access the tab? You can find here, in particular, this is the publication that is the reference for this work, Flavor Graph. And anyway, the main work has been to obtain a data set for the Italian recipes, because basically the business of La Pecora Nera is in Italy, and they want to start exploring this concept in Italy. And for this purpose, they need a data set, a tool which is casted for the Italian cuisine. Just to give you a rough idea of what is the final result. Sorry, if you go here, you have test, and again, if you put I don't know, Pecorino Romano, just to get again the same result, you get this graph in which you have the similarity of the ingredients. All the code is public available. And again, you can go to the website, and if you click in how to know more, sorry, it's in Italian again, because the business of La Pecora Nera is in Italy. You have access to the proof of concept, and the proof of concept is basically the proof of concept to get the result that I showed you before. So basically, the tools to extract the data from the web, in particular, we extracted the recipes from a pretty well-known online site named Giallo Zafferano. And okay, once you have the basically the recipes, you can build the graph. You can visualize the graph. Clearly, is a pretty dense one, and nothing very interesting here, but if you sparse the graph, you can get interesting information. And then you build embedding. This is the most, say, relevant job from a technical point of view. And once you have the embedding, exploiting not2vec, you can work with embedding, and basically you can compute, and here it is, the cuisine similarity among a test ingredient and all the other ingredients. Okay, so not surprisingly, Pecorino Romano is connected with guanciale, bacon basically, and also with pepper and with beans and so on and so forth. What is particularly interesting is that, and quite surprising, at least to me, and that's the kind of information that are relevant for La Pecora Nera, is that according to the algorithm that takes into consideration the recipe, it's also connected to, sorry, honestly, I don't know the translation of Ricci di Mare. Anyway, it's a kind of, let's say, fish. That's it. Then we moved on. Clearly, you can build embedding, not simply considering the ingredients in the graph of the recipes, but also extending this concept to chemical compound. Here, the most relevant issue is to find information about chemical compounds of each of the ingredients. And eventually, we found a nice data set in the CREA dataset. You can access it here in this website. And so basically, just to show you the final result, for each ingredient, you can get a vector that takes into consideration what are the main component of these ingredients. So the next step that we are considering to work on is related to extending the graph, also considering the chemical compounds. And in this perspective, there are at least two approaches. One approach is to, again, extend the graph. Another approach is to exploit some graph neural network techniques and consider the compounds as a feature of the nodes. Okay, so just to, conclude, what are the future work? We want to extend the graph to the compounds. Now we have all the preliminary steps to do this job. We want to consider different techniques, and in particular the graph neural network. We want to compare the score similarity provided by our tool with the ones available on other tools. As an example, if you click on some of the links that you see here, you can access similar tools. Clearly here, there is a major problem due to the major problem, and something that we have to consider. The fact that the similarity depends on the recipes, and clearly the recipes are completely different if you consider the Italian cuisine or the Chinese cuisine or whatever it is, or the French cuisine. Okay. So finally, we are now starting a nice experiment on comparing the recommendation provided by this system to the ones provided by a bot, like ChatGPT. And finally, and more importantly, we are thinking about starting an experiment on involving basically people providing their feedback, and so collecting those feedback in order to get information on whether indeed the suggested recommendations are interesting or not. Concluding, we are still in a preliminary phase, but I think that the results are encouraging. And Simone is very satisfied. If you look at the video, it's very clear that he wished to carry on the collaboration. And honestly, we are also interested in carrying on this collaboration in this interesting field of research. That's it.
Thank you. Thank you, Andrea, and Uniroma and La Pecora Nera. And with this presentation, we complete this session. And I leave the floor to Roberto and Rajesh for the discussion and final remarks.
So thank you very much for all those contributions. It was nice to see how we interact, how we as SoBigData interact with the various company. Let's open the discussion from the questions, right? So I'm asking here to Michela Natilli about the questions. So the first one is what is for SpazioDati? For SpazioDati, what is your perspective and consider what is on your perspective and considering the context of the most added value you received by the collaboration? So I think that someone from SpazioDati can answer. Giacomo.
Yeah. Okay. Hi. Can you repeat the question, please?
I think that the question actually is about the value that you received by the collaboration with the researcher. Let's say if you get new ideas, new perspective, or something like
that. Let's say we are already exploring, on these large language models, and on this task, this is a very specific task, and I think it's a good start point for an activity of using these large models for generating data, training data that we can use for other activities, for other models too. So yes, this collaboration was a starting point for using large language models for data generation. That is this is something that opens a lot of doors. It's not a direct application of these models for a software, for a user application, but something for exploring more models, more approaches for data analysis.
Thank you very much. So there is another question for transcality, which is the variability of pollution may depend on the type of vehicle. So different zone correspond to different pollution. Do you have evidence of this kind of this type? For example, restricted traffic zones, something like that.
In this project specifically, we didn't consider different traffic zones because we had one zone, right? One intersection. But in theory, of course, this can be mapped to the traffic simulation and therefore also be considered in the overall analysis. Same as different vehicle types.
Okay, thank you. So there is a question also for me, actually, for TechnoInox, which is could in principle this model be transformed into a more general tool and used for several kinds of companies' data? So let me start about for the answers. So I think yes. I mean the model it's a let's say general purpose where we have those kind of behavior in the storage, which is pretty common. So buying something and then consume it slowly in time, and for sure. I think that something that can be done for improve the quality of the results and the adaptability of it. It's also to explore, for example, different kind of regression, not only the linear one, but more complicated, which may adapt better to different situations that can be also considered case by case. I mean, case by case, industry by industry, according to the general behavior of the storage. So I don't know if TechnoInox, do you want to add something?
No, I'm agreeing with your but so the result is quite general and we must be consider the particular application and also the type of products that you want to analyze in order to best identify the current model predictor.
Okay, thank you. I don't see other question from YouTube. I don't know if we have, I mean, we have some additional comment or questions or something that you want to say. We have some time before closing. I don't see specific hands raised. So let me thank again everybody. And I think that I will leave the stage to Rajesh for a very last comment on this, let's say, this session, let's say, of the challenges. And Rajesh?
Hey, can you hear me?
Yeah.
Okay, great. So yeah, I mean, it was a great experience. We had some hiccups, which basically translated from COVID cases from previous years, but we managed. We also learned some lessons from our previous experiences, how to approach companies, how to advertise more about it, because we realized that not everyone is aware of it. So in this particular version of challenges, we used not only social media channels like Twitter, Facebook, or standard channels of companies where they are registered, but also our personal contacts to reach out. And relative to past year, we received much more applications. And then we also learned something new, that companies are somehow also not always looking for the perfect solution, but something like a prototype in between that also helps companies. So in this version, we had much more ways to help. And I think it's a win-win situation for both academicians as well as industries, because sometimes we are, as an academicians, we are not in possess of the real data, and companies who often possess the real data are looking for solutions which are not only ad hoc, but they also have some kind of sophisticated solutions which are there on academician side. So in general, I think overall I would say it was a very positive experience, and thank you everyone, both from industry as well as academicians, to collaborate and to work. And so yeah, this is not the last version. We'll have another version next year where we are looking forward for same participants to apply again, and we'll look forward more applications, and hopefully the next version would be much better. Yeah.
Okay.
Thank you.
Thank you, Rajesh. Let me add only the last things. As we said at the beginning, you will receive a message from Scuola Sant'Anna Superiore, Scuola Superiore Sant'Anna, about a small interview, a small form for an interview for everybody in order to have some feedbacks. And for sure, we will see. We hope to see you again in the next session of the challenges next year. So thank you, everybody.
Thank you. Thank you.